Okay guys, back with another extended video. This time we're going to be looking at 7.3. Now previously we looked at the graphical solution to simultaneous equations, and we saw that each linear equation, when we have two of them, unless they're coincident, anything like that, they will only ever have one point where they ever cross over. Now every equation we're dealing with here, even though it's not in the form of y equals mx plus c, even though there's a's and b's, doesn't matter. All of these are linear equations and they should be giving us one answer for where they both intersect. So first of all, we're going to do it using substitution, which is my personal favorite way to do it, and then you're going to do it using elimination. Now let's talk about the first one. Okay, we've got c equals 12b minus 15 and 2c plus 3b equals negative 3. So two different linear equations, and at one point in time they're going to cross over. Now you can see here I've got a value for c. I'm going to, oops, that didn't work the way I wanted it to, but that's all right. I'll highlight it here. We know that c is equal to 12b minus 15. I wonder if it'll let me underline. No, it has to do the whole thing. That's all right. So what we're going to do is we also have another situation with c here. So the way we're going to go about this is we're going to take our second equation. Let's focus on that one. Okay. I know formatting might be off a little bit, so I'll just backspace this back. There we go. All right. Actually, I might center them. That might be a little easier for you guys to follow. Now, the first thing I'm going to do, all right, I know that c is equal to 12b minus 15. So where I've got a c here, instead of writing c, I'm going to write it the other way. Now, this is a common mistake students will make. They will do this. This is not correct. What you have to do is put a bracket around it. Okay, so instead of writing c, I've written 12b minus 15 in a bracket. From there, what I can do is expand and then simplify. Because it's the first example, I'll do it a little bit slower. So as we expand our bracket, 2 times 12b will give us 24b. 2 times negative 15 will give us negative 30. From there, we can then simplify this one down. So there's only one constant, the negative 30, that stays where it is. 24b plus 3b will give you 27b. Notice this minus here is only, and I'll repeat, only attached to the 30. So what we end up with here is 27b minus 30 is equal to negative 3. From there, it's just simple rearranging. If I've got minus 30 over here, it'll be plus 30 over here. That's going to give us 27b is equal to 27. From there, 27 divided by 27 is 1. We end up with a value of b is equal to 1. And there's the solution for that one. All right, we know what our b value is. We can go back and we can find what our c value is. Okay, so now that we know that b equals 1, let's go back. Let's take this equation. You could use either, but we're going to take this one. To prove my point, I might do the other one as well. We'll substitute the b for 1. Okay, 12 times 1 is 12. 12 minus 15 will give you negative 3. So what we end up with is c equals negative 3. Okay, let's see if that holds true. What I'm going to do is take this side over here. Oops, sorry. And substitute our original b value of 1. Okay. Now, what we end up doing, we'll expand this one out first. So we get 2c, 3 times 1 is, 3. Okay. Then what we do is we move the 3 over to the other side, making it a minus 3. Now, when we subtract 3 from the other side, minus 3 is actually going to be minus 6. 2c is equal to minus 6. The opposite of timesing something by 2 is dividing by 2. Negative 6 divided by 2 will give you minus 3. Okay, notice how we get both the same c value there. Okay, so there's your answer for part A. Let's go through and do part B together. Now, I am going to be skipping a little bit of working when it comes to this one. Now, this one is a little bit different because what we have is y equals 4x plus 6 and y equals 6x plus 2. Now, there's nothing stopping you, for argument's sake, rearranging the left or the right one, getting a value for x, and then substituting it into the other one like we had up here. Notice how one was an exact c value equals, and we just substituted it in here. Now, we can still do that. What we have is we have two values for y. What that means is, plain and simply, is that 4x plus 6 is equal to 6x plus 2, because y is equal to y, isn't it? Instead of writing my first y equals, I'm just going to write 4x plus 6. Instead of writing y, it's going to equal 6x plus 2. Now, from here, we can go about solving this, albeit with a little bit of rearranging. Now, the very first thing I want to do is center these properly. Oh, I'm not sure why it's doing that. That's all right, though. So first of all, I'm going to move the negative 6 over to one side and the positive 6 over to the other. All right, so that's going to be minus 6x on one side. The 6x is now gone. And then it's going to be 2 minus 6. Okay, so just to reiterate, all right, I just realized the 4 on the x disappeared, but that's okay. There it is. That 4x stayed the same. Minusing 6x. Minusing 6, and the 2 stayed the same. Notice that 2 is still positive. All right, from there, we can simplify it down again. 4x minus 6x is minus 2x. 2 minus 6 is minus 4. Then you just rearrange. Negative 2x is equal to negative 4. That means that x is going to be equal to negative 4 divided by negative 2, giving us a value of 2. Okay, again, I'm just going to quickly substitute in this video. So we've got a value of x equals 2. Let's go and find our y value, and I will actually do the working for that. I won't shortcut that. So what we know is that this value is going to be 2. So I'm just substituting that in there, and let's do the math. Okay, so 2 times 4 is 8. 8 plus 6 is 14. There's your final answer, y equals 14. Now, if I sub the x equals 2 into my other equation here, we should also get 14. 6 times 2 is 12. 12 plus 2 is 14. This equation is telling me that y is equal to 14 when x equals 2, and that matches. Y equals 14. So there we go, another successful case of substitution. Now, for this one, I'm just going to go over the page. Okay, so we've got 3x plus 2y equals negative 1, and y equals x minus 8. So again, we can absolutely just substitute this one straight in for the value of y over here. What that's going to give us is the following. So copying and pasting it down. Instead of writing a y here, we're going to put a times, and I'm going to put a bracket. So x minus 8. All right. So it still holds mathematically true. We just have a different way that we can actually write down y. Right. From there, we expand this bracket out. We should be getting pretty good at this by now. So that's going to be 2 times x, which is just 2x. 2 times negative 8 is negative 16. So that's that top bracket expanded out. 2 times x is 2x. 2 times negative 8 is negative 16. And that's all equal to negative 1. From there, once again, just simplifying our values. 3x plus 2x is 5x. I'll move the minus 16 to the other side, making it plus 16. Negative 1 plus 16 will give you a total of 15. Then you've got 5x equals 15. The opposite of timesing is dividing. So 15 divided by 5 will give you a grand total of 3. Okay, so we know that x is equal to 3. Okay, again, this time we're going to use... I'll show you that you can use the same one. So we'll go this one here. Okay, a little bit familiar. This time we know that x is now equal to 3. Okay, so this is going to be times 3. Now, if you're wondering why I haven't been putting a bracket around this part of the substitution, is because it doesn't achieve anything. It doesn't help us. Whereas up here, due to BOMDAS, we need to put brackets around it. But I'll prove that the bracket does nothing. Let's go and solve this one. 3 times 3? 9. Okay, now what we're going to do is move that 9 over to the other side. That 9 was originally a positive, so it becomes a negative. We get 2y equals minus 1 minus 9. That's going to give me 2y is equal to minus 10. The opposite of timesing is dividing, so that's going to give us y equals negative 10 over 2, which is negative 5. Let's see if this, sorry, that 2 should be gone there. Let's see if this holds true for us, okay? I should be able to sub this y value of negative 5 in here and get an answer of 3, okay? So here I've got y is equal to x minus 8. That means negative 5 equals x minus 8. Negative 5 plus 8 is 3, matching. So there's your solution for that one. Okay, I know it's a fair bit of working, but trust me, practice will make perfect with this. I often find, highlighting the different things, like as I showed you earlier, highlighting this and even using brackets will help you immensely when you're doing these problems. Over here, we've got a couple of questions. Now, we have to do these using elimination. You could absolutely do this using substitution, but that's not what we're assessing here. We're assessing your ability to use elimination here. Okay, they're the three methods we learned for how to solve a simultaneous equation: graphically, substitution, and elimination. Now, elimination I've always been a bit stuck with, but I'll teach you an easy way to do this, because effectively what you're doing is like when you've got a deck of cards and you're shuffling it. Okay, you might split it into two, wedge it between some fingers, and kind of riffle shuffle it. That's effectively what we're doing here. We've split our deck into two equations, and now what we need to do is riffle shuffle these together in the hope of eliminating something. Okay, now just before I go any further, just as an example, if I had, say, and I know I've gone to a new Word document, this is just a little bonus for you. If I had, say, 2x is equal to y, that's just an algebraic equation. I could add 1 to both sides and it would still hold true. I could then take each side and say times it by 3 and it would hold true. Okay, I'm sticking to the rules of mathematics. Okay, however, if I then said, okay, I'm going to subtract y from this side and left it like that, then that doesn't work. Okay, it's no longer going to hold true. So going over it here, the whole goal of elimination is when we riffle shuffle them together, we do it to try and eliminate something. Now, we do that through either addition or subtraction. Now, let's have a look here at which pronumeral would be easiest to eliminate. And I can see it right here. I reckon we can try and get rid of this y. Now, the factor is we have to think about, if I merge these two together using addition and subtraction, how am I going to get rid of that y? I've got a positive and a negative y. Well, going back to our blank document, again, I just didn't want to muck around there. If I had, say, y minus y, that would indeed give me 0, okay? Now, the thing is, though, if I try and subtract, I'll put this in brackets, if I try and subtract this, okay, it's going to be negative 4x minus negative y, so you're actually going to plus y. So you're going to end up with y plus y giving you 2y. That doesn't eliminate them, okay? So first thing I'm doing, just putting each in brackets, okay? Now, my following step is where I'm now going to start the elimination process. Like my riffle shuffle, I'm going to move these together. Now, I mentioned earlier, looking at here, we want to subtract. So we move this one kind of up like a little arrow in here to make it 5 minus 2. That 2's been riffle shuffled in. Now let's riffle shuffle this in. Minus 4x plus y. All right? Now we can get rid of it. What we've effectively done here, grade 11, is I've merged the two together to begin the elimination process. Now, it might not look like it now, but, sorry, that should be, I just realized I've done minus here, and that's not going to give us the correct answer. There should be a plus. My apologies, guys. And I'll show you why. Okay, caught this mistake early. When I expand this bracket out, it's going to give me minus 4x and then plus y. Y plus y is 2y, doesn't eliminate it. We have to add it, okay? That means that this is also a positive. My apologies for the little mix-up there. Now, I know we've got brackets. We actually don't need them at this point. Okay, we can expand this out. Positive 1 times 4x is 4x. Positive 1 times negative y is negative y. So this bracket is actually going to stay the exact same. Oh, I can just eliminate. Didn't want me to eliminate that for some reason. I'll just rewrite it. 4x minus y. And over here, 5 plus 2 is 7. That also means I can get rid of the bracket over here. It's not helping us, so we have 3x plus y. From there, we can actually look at solving this, because remember, the whole point of the elimination method is to eliminate a variable. So here, collecting like terms, 3x plus 4x is going to be equal to 7x, and we can eliminate that now. And here we go, here's the magic. Y minus y is going to be 0. So it's plus 0, which we can just get rid of. We end up with 7x is equal to 7. Finalizing this line of working, 7 divided by 7 is 1. We end up with x is equal to 1. There's our answer for the first one, okay? I won't center this just for this sake, all right? Let's go down to our next one, okay, in B. We've got 2a plus b equals 7. A plus b is equal to 5. Now, again, we have to pick a pronumeral that's easy to eliminate. And straight away, my eyes are drawn to this, b. Now, I've got a positive b and a positive b. So how do I eliminate two positives? Well, I can't add them, because if I did positive b plus positive b, I'd end up with 2b. If I did subtract, just like I did in my example up here, okay, they would be eliminated. Okay, so now we're doing subtraction. Okay, we did addition up here, sorry. Now we're doing subtraction. Again, just like I did before, I like putting brackets around everything. All right, just to make it a little easier. Now we're riffle shuffling. We're going from here up to here and here up to here. It's always afterwards, okay? Obviously for addition it doesn't make a difference, but for subtraction it does. So it's better to do it one way to save any potential confusion. So minus a plus b, and then it's going to be 7 minus 2. Didn't need brackets for that right-hand side, because it's just a simple subtraction. From here, now, this again, if you didn't put the brackets and you just did it like this, you would be incorrect, because the minus is only applying to the a and not the whole term. When you expand this bracket out, there's an imaginary 1 here, so it's negative 1 times a, which is minus a, negative 1 times positive b, which is actually minus b. Okay, now you can see how the cancelling is going to work. All right, collecting our like terms, this is what we end up with. What did I put 2? That should be a 5. Knew something didn't look right. 7 minus 5 is going to give you 2. I was jumping ahead there. Okay, collecting like terms. This should also be a 2. Sorry, guys. So we've got 2b. That should be an a. What am I doing? Sorry. Okay, just double checking. Okay, we're good now. Sorry for that. So 2a minus a is just going to give us a. If you have $2 and you lose $1, you're left with just $1. We've got, sorry, get rid of that a. Now we've got positive b minus b. That's going to give you plus 0, which is just equal to a. This one was a little bit easier. We just get a is equal to 2. Now, I've just realized I haven't actually gone back and found the other value for my question up here. Just like we did over here, once we found b, we had to find c. Let's just take this second one now. I'll quickly go back and solve for this one. So 4x minus y equals 2. X is equal to 1. 4 times 1 minus y is equal to 2. Let's go about expanding and solving this to get our value for y. That's going to give you, get rid of the brackets, 4 minus y is equal to 2. From there, move the 4 to the other side. We get negative y. Don't worry about the negative. That's okay. Negative y is equal to 2 minus 4. Okay. That's going to be negative 2, obviously. Now, this is where students often freak out. They don't know how to get rid of this negative. So what we're going to do is y, I'm just going to expand that out a different way. It's actually equal to negative 1 times y, isn't it? The opposite of timesing is dividing. We're going to end up with y is equal to -2 over -1, which is just going to give you 2. There's our y value, y equals 2. Now for this one, we found the a value. Let's go find the b value. This time I'll use the top equation. Okay, it doesn't matter. If you want to use the shorter one, go for it. As long as you follow the math rules, you won't have a problem. Here, I'll speed it up a little bit. It's going to be 2 times 2 plus b is equal to 7. 4, that's going to be 4. So moving to the other side, b is equal to 7 minus 4. B is equal to 3. All right, I'll quickly double check that with the working here. Yep, there we go. 3 is absolutely correct. So there's b done. Now we get to the hardest question in this video. When we look at this one in terms of how we eliminate it, the first thing you're going to notice is that there's no singular coefficient. Okay, sorry, not coefficient. There's no simple term there. Okay, with a coefficient of 1. They all have different coefficients. Okay, notice here, b and b, y and y. Yes, one was negative and one was positive, but we showed here that we can just do different operations to fix that. Okay, that's not a problem. But down here we have a bigger problem. Okay, and that is that these aren't to the same, or don't have a similar pronumeral. That's okay. It's easy to fix, and I'm going to show you how we do that. What we do is we apply that that logic from earlier. So I mentioned if we had, say, 2x is equal to 3y, we could add or subtract. As long as we do it to both sides, it isn't a problem. Okay, what we're going to do in this case, for example, if I did say times this side by 3, I would have to times the other side by 3, okay? But that would still hold true. That's not a problem. Now, going here, we need to find a common term for these guys. Now, looking at this, I'm going to pick the c's. I've always picked the right term. Let's pick the c's here. Now, they've got a coefficient of 3 and 2. So what do 3 and 2 share in common? Well, the lowest common number they share in common I can think of is 6. Now, how do I turn this, and I'm just going to put both sides in brackets, even the 5. How do I turn this 3c into 6c? Well, I do that by timesing it by 2, don't I? So this side, I'm going to times by 2. Whatever I do to one side, I do to the other. Now, where students make mistakes in elimination is the following. They go, oh, well, if I times that one by 2, that means I have to times my second one by 2. Incorrect. If we were to multiply this by 2, let me show you what would happen. All right, we'd get here 2 times 3c is 6c, 2 times 2c is 4c. It didn't actually help us, did it? We were trying to get them both to a lowest common factor, okay? And that common factor was 6. So how do I turn this one here, the 2c plus 3d, how do I turn 2c into 6c? Well, I times it by 3, don't I? That means this side also has to be multiplied by 3. From there, I can take this and now expand it. So this is going to give me 2 times 3c, as we mentioned earlier, is 6c. 2 times 4d is going to give you 8d. That's equal to 2 times 5, which is going to give you 10. Just double check my working. 2 times 3c, 6c. 2 times 4d, 8d. And then 2 times 5 is 10. There's my first one expanded. Okay, my second one is going to be 6c plus 9d. Okay, and what that's going to equal is 3 times 4, which is 12. So now you can see grade 11. I'll just quickly get rid of the spacing. Oh, no, that didn't like that at all. We'll have to keep it like that. So what I'm going to do now is put brackets down the bottom one, because that's usually the one that we move to the top, like our riffle shuffle. Okay, now what we're going to do is we're going to merge these two. Notice I've got that common 6c that we can eliminate. Now, think about it for a second. Do we subtract or add here? I'll give you a few seconds to think about that before I tell you the answer. All right, so what we're going to do is actually subtract. I've got positive 6c and positive 6c. The only way I'm going to change that is if I subtract them. So my new riffle shuffled equation is going to be as follows. Notice I followed the exact same procedure. I haven't got the bracket around the 12 because I don't need it, but I do need it here. Okay, follow the same procedure. Okay, you don't technically need a bracket around this one here, but now what we're going to do is simplify it, and you'll see why. So, -1 times 6c is just minus 6c. Sorry, might have to delete that. Minus 6c. Minus 1 times positive 3d is minus 3d. If you didn't have the brackets around it, that 3d would stay positive, and there's your mistake. That's where you're getting the wrong answer. All right, now we simplify by collecting like terms. I should have simplified that side, but we can do it on the next line down. 10 minus 12 is minus 2.
Owner of Orange Kia Rio 176X.
Apologies for that little unscripted little announcement, guys. What we're going to do now is solve for the rest of this one. So, I've got 6c plus 8d minus 6c minus 3d equals minus 2. Collecting these, 6c minus 6c, as we mentioned earlier, eliminates those. So the 6c's are gone. That's the whole point of elimination. One of our pronumerals disappears. 8d minus 3d is 5d. Okay, from there, we simply swap them over. -2 over 5 is basically negative 0.4. There is our final answer for D. Now we can substitute D into our equation up here to get an answer for C. What I'll do is I'll just quickly do that in my head, okay, just to make this video a bit shorter. Okay, so C, let's do for the first one, okay? So if D is equal to negative 0.4, use my calculator. It's going to be 4 minus 3 times negative 0.4. That's 5.2. Divide that by 3. I can't be right. Oh, sorry, it's divide by 2, not divide by 3. I'll have to do that again. Sorry, guys. So 4 minus 3 times negative 0.4. 5.2, divide that by 2, I get C is equal to 2.6. Let's see if this holds true. Now, I'll substitute that into the top one now. My value of D equals negative 0.4. So that's going to be 5 minus 4 times negative 0.4, and then we divide that by 3. Get 2.2. So it looks like I might have made a mistake here, guys. Let's just double back and have a think about where this mistake may have been. I might actually just do the full working, just to be on the safe side. Mistakes do happen, but that's okay. It's all about how we go about backtracking. So I got different answers when I did this. So let's go up to the 5 first. Did I expand that correctly? The 8D is correct, the 6C is correct, and the 10 is correct. Now, this bottom one I multiplied by 3. I got the 6C correct. I got the 9D correct. There we go. I've found the mistake I've made. So, some of you may have caught it in the video, but for some reason, I accidentally read off up here, this should be 9D. But in checking my answer, I realized there was a mistake. So this is actually a good little learning experience for those watching the video now. This should actually be minus 9D, okay? Now, again, following our pattern down, 6C minus 6C is still going to eliminate itself. 8D minus 9D is actually going to be -1, or just negative D, I should say, okay? From there, the negatives cancel out. We're going to end up with D is just equal to 2. Okay, using the process that we did before. Now I'll do some quick substitution, okay? So D equals 2. 4 times 2 is 8. 5 minus 8 is -3. That's going to give us a value of C equals -1. Now, when I substitute D equals 2 into the bottom one now, I should get C equals -1. So 3 times 2 is 6. 4 minus 6 is -2. -2 divided by 2 is -1. There's our answer, guys. So even though I made a mistake, it only took about 1 or 2 minutes to correct it. But again, I started all the way up here. I checked if my expansion was correct, and then I realized I made a process error here. Okay, copying, instead of writing 9D, which I had correct, I accidentally wrote 3D looking at this example up here. That mistake carried through, and only when I double checked my answer did I realize that there was a mistake. Anyway, guys, I know it was a longer video. Elimination and substitution can be quite difficult, but that's everything for you.